Let's start with our exercise 01, the Fibonacci sequence. Now let's first see what is actually a Fibonacci sequence. Okay, so the sequence actually starts with 0, then 1, then 1. Let me write it down first a little bit. 3. So the first element in the sequence is actually 0. The second element is 1. Okay. Now the third element in the sequence is actually just the summation of the last two elements. 0 plus 1 is equals to 1. 0 plus 1, that is actually 1, that is the third element. Okay. Now the fourth element is the summation of previous two. 1 plus 1, that is actually 2. Then 3, that is the third, then that is the fifth element. 3 is the summation of last two. 1 plus 2 is equals to 3. So 3 plus 2 is equals to 5. Then 5 plus 3, that is equals to 8. Okay, 5 plus 3 is equals to 8. Then 8 plus 5 equals to 13, and so on, this way. So this is what is called the Fibonacci sequence. It actually increases this way exponentially. So in our exercise, in this problem, we are asked to find the nth Fibonacci number. So this is our first, second, third, fourth, fifth, this way. I are asked to say, for example, the 20th Fibonacci number. Okay, so that is what the objective of this program, of this problem. Now the question is how we can actually do that. So if you actually understand the pattern, that is actually the pattern is very simple like this. That is called our Fibonacci of I, that means the iterator variable I, is actually the Fibonacci of I minus 1, the previous Fibonacci number, plus the Fibonacci of I minus 2, the previous and previous. That is the actually the basic algorithm. This is something that we want to implement, and to do that we need to use a for loop for that. Okay, and we'll do that writing a function. Okay, so let's take a look. So here, as you can see, if you remember, we can just define a function like this way. Function out is equals to, let's name our function as fib. That's completely fine, and it is going to find out the nth Fibonacci number in. Okay, so this is fine, and let's end it. Let's save it in our location. Okay, it is saved now. So if we look here, the first two, that is the first two number was 0 and 1. We have to predefine it. We have to define it, and we have to find out from the third element and fourth element. Okay, so if I define it first, say for example, we define out of 1 is equals to 0, out of 2 is equals to 1. So out of 3 should be 0 plus 1, out of 4 should be 1 plus 1, the last two summation. So we can actually find that using a for loop. So we can write this way: for I is equals to 3, from the third element to the nth element, we want to calculate up to the nth element. So from 3 is to n. Okay, so out is equals to, we want to append the next element to this matrix, to this array that we are creating, out array. If you remember, if I write something like this, like 0 comma 1, okay, that is what we have done here. Out of 1 is actually defined as 0, out of 2 actually defined as 1. That is what we have done here. If I want to add another element here, we can just write it something like this way: a is equals to a comma 5. That will be appended, if you remember from some of the previous lectures. So we can actually do it like this way. Let's see. So out is equals to out comma, and the output, the next element should be the summation of previous two. So we can actually write this way: out is equals to out of I minus 1. Since I is 3 in the first iteration, it will take the second element plus out of I minus 2, then the first element. Okay, then end it, close it, and end. So if you look at it, when I is equals to 4, so out will become third element, the plus summation the second element, and so on. Let's take a look. Okay, so if we call this function, say for example, if I call this function here with Fibonacci of, say 5. So as you can see, first the element actually the output actually becomes 0 1 1, then becomes 0 1 1 2, then 0 1 1 2 3, and that is the output. This is the fifth element. So I have to take out the last element. That should be our answer. Our target is to find the nth element. So for n equals to 5, I need the last element. So we can actually just write our out is equals to out of end, that is the last element. Okay, and this is the answer. So for example, if I want to find out the 15th element, so 377. Okay, so 377 is our 15th Fibonacci number. Okay, I believe you got the idea. And um, there is another one in the exercise that is called the 15 Fibonacci sequence. Fibonacci sequence is quite the same. Please search the Wikipedia or the Google to see what is the Fibonacci sequence and try to do this by yourself. Okay. Now, one other thing that I actually mentioned here, that is called recursion. Now, I am not sure whether you have actually learned this thing, recursion technique, in your C programming language. If not, then don't worry about it. But if you already know recursion, okay, due to the time shortage, I cannot actually cover it here in this lectures. So you can actually solve this problem using this recursion technique as well. But if you remember this TikTok, if I in the last lectures I have shown you TikTok, I can actually compare between two programs how much time they take. So if you actually solve this problem using this recursion technique, and then again the one that I actually just showed you, so if you differentiate between these two, you will see this approach will actually solve the problem much faster compared to this recursion technique. Okay. Now, if you don't know recursion, then just ignore this portion. Don't worry about it. You don't have to worry about it. So I believe this is okay. But before I actually finish this thing, I want to give you some idea. Okay, give you some idea. And if you look at our code here, you will see. If you remember, I told you this is the warning bar. Okay, and if you look at it, it is actually showing an warning. If I close it, still there is another warning here that is called, if you read it, okay, the variable out appears to change size on every loop iteration. Consider pre-allocating for speed. So what does it actually means? Now if you can just do it up to this point, that means your program is running, that's completely fine. And at this beginning stage, if you can do up to this way, that's completely fine. You don't have to worry about anymore. But I just want you to give you the understanding of how actually you can make your program run very smoothly. Okay, so let's try to understand what does it mean. So when you are actually running this code, if you see, and it actually meaning that your output, that is output is actually increase, the size is actually increasing at each step, because we are appending some element to this array. So at the first stage, so what we are actually doing, the first stage it was 0 and 1, then second stage it becomes 0 1 and 1, third stage it becomes 0 comma 1 comma 1 comma 2, and so on. That means the size of our original array was increasing with each stage. With each step it was increasing. But what is the problem with that? The problem is actually, so we have defined our output variable as out. Okay, and your processor, your computer actually stored this matrix, stored these things in a location. Okay, in the memory it has actually stored it. But when you are running when you are actually running the for loop, okay, at each stage you are increasing its size. Okay, you are asking at each iteration, you are asking your MATLAB, okay, you are asking your processor to increase the output matrix size. Okay, at each stage it is increasing its size one by one, and that is actually taking some time to do it, because the memory is located, memory allocation is actually doing, at each step it is increasing. So this actually takes some time to do it. So instead of doing that, there is actually a better approach. That is, say for example, we are trying to find our elements for n equals to 10. That means we want only the first 10 elements. Okay, so our output matrix, our final matrix, okay, our final matrix will have a size of 10 elements should be there. Okay, if you remember, so it should be like here 0 comma 1 comma 1 comma 2 comma, total 10 elements should be there, right? Total 10 elements should be there, and we already know that. Since we already know that, okay, we can just, instead of defining it this way, we can just, at the beginning of the for loop, we can just say our output matrix will be size of 10. Okay, and if we do that at each stage, okay, say for example I say each of the element, say I say each of the element is 0. At first I say each of the element is 0 of our output matrix. Then at each step of the iteration, okay, I place an element, I find out what is the next element and place it here. Find out what is the next element, place it here. In that way, in each step of the iteration, your output matrix size is not increasing anymore. It is constant. So for that, your processor does not have to allocate the memory space again and again at each step. So if you are running the iteration for say 100 loops, it has to, if you do not do this way, your processor has to allocate those things 100 times, and that is going to take a lot of time. So instead of doing that, we can use this approach that is called pre-allocation. Pre-allocation, and it is actually a very simple thing to do. The concept is actually very important to understand. So instead of doing that way, we are going to do a little bit different. Let's just copy it. Okay, let's just copy it and write it. So we define our new function as Fibonacci 2, and here I actually made a mistake. There should be an end. Okay, and this last line should be out of the for loop. Okay, just keep it here. So if we run our this matrix, and let's see our output. Okay, that is our Fibonacci 2 of, say we want to look at the first 8 elements. So now as you can see, at first our original array was of size 8 because we want the 8th element. So we define our array as of size 8. Then at each stage of the iteration, we are just finding the new element and placing it in our original array, just placing it with our original array. First we define it as zeros and just place the new element there. In this way, when we proceed, we are not actually increasing the array size again and again. So our processor actually fixing our original array at a fixed position and just putting some value in there, placing some value in there. Okay, and if we actually using the tick-tock, if you actually try to compare between these two, you will see this one will be like 10 times more faster than the previous one. Okay, so the key takeaway from this thing is that whenever you are using this, whenever you are writing a program, if you already know your output matrix size, okay, so please predefine it first. Okay. Predefine it this way using a zeros or ones, something like that. Then run your for loop. That will actually run your code very smoothly. Okay, and this is a very these are some subtle technique of programming. Okay, and that I want you to know at least, so that you can actually implement this in your real life problems. And I hope you got the idea. Okay, so let's finish this one.